This share. How is everyone today? Please get an interesting picture. There's always Brady's. Oh,
Yeah.
dear, wow, that was a little loud. That kind of hurt.
I'm far away from my mic, so I don't know why.
Oh,
You can hear that.
I just had the volume turned up on here.
Okay.
How is everyone this morning? I guess it's Thursday, I think. I don't know. Um, I'm sorry, I just kind of blanked yesterday. I went and looked over the assignments that have come in and I replied with a comment or two. It's, I mean, there were little things kind of here and there about the trig stuff. I've got one, I closed that folder, that I'm going to probably put up today or tomorrow about all the transformation stuff. Um, how much per se we're going to do. I'm going to go over a few things today. Mrs. Legier used to do this awesome thing in groups where you got to do this crazy big draw your flip chart and all of that. But we can't do that because we can't meet in groups. So I just want to quickly, oh, apparently I did not finish that part of, oh, I don't want to do it in invisible ink. I want to do it in a regular pen. What's going on here? Um, just quickly look at the stuff from Tuesday. I think this is translation, translation, stretch, stretch. So this is a vertical translation of 5, 2, 1, 1, uh, -6, 0. That's in front, so it's a vertical stretch of 2 and 1. Sorry about this. So this is vertical 0, -3, a half, 1, a third, -2, +7, 1. Holy cannoli. -8, -6, 4, and 1 half. I don't know if anyone has gone through the stuff that's in orange were the mapping rules. And like I said, it's just going back and forth here. We did those ones together. 2 times f of 1/3 of x gives a mapping rule of 3x and 2y. So we just multiply and stretch it out. There's a negative out in front, so that this one was kind of different. That negative goes with the y part. If x is negative, you're going to see a negative in there. So x plus 3, -2y plus 1. That one is a reflection about the x-axis. And that one had a reflection about the y-axis and some funky stretches. I think that was all. So I'll save that and I'll re-upload all of that. So this is um, kind of what we've looked at. The RFs are the outcomes per the curriculum. Um, it just, they're all really, some people think, oh, well, you have to title everything and this and that. And it's like, well, I don't know. I don't think I've met very many kids who've actually looked at the curriculum. So RF1 is translations, moving it left or right and up and down. Stretches, stretching the X or stretching the Y. And this has the B as positive and then 1 over B. There's that reciprocal relation. Everything together. And that's, we're going to talk a little bit about reflections. This is the new stuff. Um, and really today is just going through some mapping examples. I'm going to give you some questions to look at from the book. They're not necessarily going to be assignment type questions. Um, but when we have an assignment on this, which I think I have one, and I'm going to try to put it up today or tomorrow. It depends on my wife's meetings. I was going to go down the basement, but apparently she has a meeting at 9:45. So, yeah, working from home is super awesome. So reflecting, if we put a negative in front, we're reflecting across the x-axis. And that's not right, because there's your x-axis. Reflecting across the y-axis is there, and reflecting, this is kind of the different one. We've looked at um, these sorts of things with quadratics. When you did a parabola, if you have negative x squared, it opens down. So we reflected it across the x-axis. For a quadratic, it doesn't really make a difference if we reflect it across the y because it turns into the same thing. For the sine function, this one actually would come into play. And then we can reflect it across a diagonal line of y equals x. So if y equals x, the reflection, the thing to notice is we've changed x becomes y becomes x. And I think there's an example of that here in a minute. And then we'll look at some tomorrow, some kind of practice sort of stuff. So draw the graph. A lot of it is, well, apparently, oh, it's the same sort of thing. If y equals negative f of x plus 3, the mapping rule, there's nothing inside the brackets, so x goes to x. We're going to go to negative y plus 3 is our mapping rule. So point A is 1 and negative 2. B is 1, sorry, negative 1 and negative 2. 1 and 2, 3, 4, 5. And C is 1, 2, 3, 6, and 2. So because we have this negative in the y, we're going to be reflecting it across the x-axis. I think let's just negative f of x, yeah, reflects it across the x. So our mapping rule, well, our x values are all going to stay the same. Negative 1, 1, and 6. So negative of negative 2 is 2. 2 plus 3 is 5. Negative of negative 5 is 5 plus 3 is 8. Negative of positive 2 is negative 2 plus 3 is positive 1. So negative 1 and 1, 2, 3, 4, 5. B is 1 and 5, 6, 7, 8. There's a difference of 3 here. There's still that vertical difference of 3. We've just shifted it up to help us look at it. 6 and 1. And I can change my color. Well, I'm using blue now, so A. Oh, I gotta label my points, sorry. B prime, C prime. So if you calculated the slope between B and C or A and B, like this is 2 and 3, this is still 2 horizontally and 3. It's just, it's been reflected and then shifted up 3. So if I reflect this point, if you do it kind of sequentially, if I reflect this point, it's going to go to there and then up 3. Negative 5 goes up 1, 2, 3, 4, 5, and then up 3. reflecting this one goes down to here and then up 3. So you can, some people will do these all, if you're doing, stating them and doing each one in turn, you would do the reflection first and then shift it because that's just the logical way to do it. So oh, this is going to get fun graphing. Yeah, well, we'll put it on here. Where's my pen? Oh, I know why that's there. Different color. That's out in front. So the y, oh dear, a half of the y values, a negative x, that 4 is still positive, so negative x plus 4, negative 1, negative 2, 1 and negative 5 was, 6 and 2. So now, oh, that one's going to be messy. Arrows. So negative of negative 1 is 1. 1 plus 4 is 5. Negative of 1 is negative 1. Negative 1 plus 4 is 3. Negative 6 plus 4 is negative 2. A half of 2, so that's negative 1. A half of 2 is 1. Oh gosh. So a half of that is negative 5 over 2. That's going to be spectacular to graph. So A, I would call this, because we have A double prime, B double prime, C double prime. I labeled those. So 5, 1, 2, 5, oh, and negative 1. So that's A double prime. I'm going to get rid of those green bits because they're just going to get in the way. And now I've got crap all over, sorts of messed up. So this one's reflected and then moved over. This one would be reflected and then moved over. So that one is 3, and then it's vertically stretched. So 1, 2, 3, a negative 5 halves is negative 2.5, which is in there, give or take, and negative 2 and 1, because C is flipped to the other side. So now all of the slopes, if you were to look at them, are cut in half, but the A is on the opposite side of the y-axis. The B, well, reflected over and then shifted. The C reflected and shifted. It's the same kind of idea there. Oh, x equals f of y. So this is, whoa, I don't want a line. Let's do this in green for fun. Reflection, y equals x. So I can draw the line y equals x. I know it's a line that goes through the origin that has a slope of 1. So give or take, that line, that orange line there is the line y equals x. So this point is going to go onto the opposite side of this. C, like we're moving all of those. So A is negative 4 and 0. B is negative 2 and 3. 1, negative 2. Oh, 1, 2, 3, 4, 5, 6, 7, 8. Okay. 9 and 2. So this is something you would have to pay really close attention to should we have a test. Uh, if we had a test. Um, because this is something that if you're going through and trying to do stuff quickly, this is something that is easily missed. People don't often miss a negative sign. It happens, but it's not that common. A mistake in this with the X part not doing the reciprocal of the stretch or switching the sign. But this one, if you're rushing through, you're not going to notice that this is X. Whoa, XY goes to Y and X. So if the original coordinate is -4 and 0, the reflected coordinate, well, I'm going to take the Y and put it first, 0, and then the X is -4. So this is really X and Y, 3 and -2, -2 and 1, 2 and 9. So it's the same idea. A goes to 0 and -1, 2, 3, 4. So this is A prime. So this point is kind of two diagonals, 1, 2, 3, and -2. So there's that point there. B prime. C is -2 and 1. And then D prime, 2 and 9. So the general shape of the graph is all the same. Let's see if I can not mess this up. I think it's technically that green. A, B, C, D. And if I could group those, I actually could rotate them around. And it's similar to actually a rotation. So in this course, we talk about transformations as translations, up and down, left and right, stretches. You actually can do rotations. Um, they get a little bit more complicated. They actually involve trigonometry, um, which I remember doing in university for sure, maybe in high school at one point. And now comes to the point where it'd be like, okay, try this one on your own if we were sitting in school. But we can't really, but this one has a whole bunch of stuff. Y equals, so we don't have to worry about that y equals x. So, whoa, what was that? Oh, let's try a different color. I haven't used purple in a while. All right, so, well, let's label our points. A is -2 and 1, 0 and -2, 1, 2, 3, 4, 5, and 3. Worst case, label your points. That's our start. So our x bit, well, I've got a negative, so -x, subtract 2 becomes +2, comma, a -y, -3. So we don't have to worry about, so this one we're reflecting the point in the x-axis and the y-axis, so it's going to look a little funny. Negative of -2 is 2. 2 plus 2 is 4. Negative of 1 is -1, minus 3 is -4. Negative of 0 is 0. Negative 2 plus 2 is 0. Negative of -2 is 2. 2 minus 3 is -1. And negative of 5 is -5. Plus 2 is -3. Negative of that 3 is -3. Minus 3 is -6. Whew. All right. Now we need to plot 1, 2, 3, 4. 1, 2, 3, 4. We've reflected it over here. We've reflected it down there. We moved it over 2. and down 3, reflect, reflect, over 2, down 3. Yeah. A prime 0 and negative 1. We reflect in the x or in the y-axis. So we reflect up to here. Oh, and down 3, reflect over there and nothing. So b prime, negative 1, 2, 3, 1, 2, 5, 6. C prime, reflect, and the order doesn't really make a huge difference. Reflect over to here, reflect down to there, over 2, down 3. Let's connect the dots. La 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 la. That one, A to B to C. And that's our new graph. So tomorrow, I was going to give you a bunch of, this is the one I want. Oh, we're good for time. I got a few minutes. All my videos. So yeah, I've got my screen shared. Somebody would have said something by now. Um, I think I was going to give you questions from the book, but what I might do instead, oh, there's 10 pages of that. Hot dog. Because I'm guessing a whole pile of you don't have your books. That would be my guess. Um, this is, these are the things we, at this point, should be able to do. And this has write a mapping rule, write an equation, state the transformations. So I'm going to actually instead, well, some of this, I don't know about some of these, but I'm going to post this when we're done and at least try to do 1, 2, and 3, or 1, 2, 3, and then 2, and then 3. This is your numbers like I do. 1, 2, 3, 2, 3, 4. Um, like start that instead of doing questions from the book. I'll go over some of it tomorrow. I'm going to post, I mean, whether I open it or not, we'll use this as our transformations thing for now. I heard an interesting thing last night. I was talking to um, Mr. Ryu and Mr. Casey, and they're both, Mr. Casey's at Harborview, Mr. Ryu's at Hampton, and I haven't really been paying attention to other provinces, but they've effectively said, yeah, school is done, even though we're, as a province, doing amazingly well with this whole pandemic thing, and you're going to start to see some things start to open up. I don't know about next week, but um, this is, we're not going to have an out of thing, but this will be kind of the, I might shorten a couple of the questions out, but this is the assignment. But the rumor is PEI didn't technically close everything like we did and say, nope, everything's done. So there's a chance PEI students could go back to school in a few weeks. And we were like, wow, what would happen there? Well, we told you nothing counted in all of this. And now we're saying, no, you have to go back to school. And I said, I don't know what that would mean. I don't know what that would be. But it's a bridge to cross later. So we today looked at reflections. I'm going to post this and say, start to do the first little bit of it. You don't have to copy that. Hopefully everyone has some graph paper. If you don't have graph paper for a question like this, at least list, okay, here are my, okay, write your mapping rule. Or, well, this said what is the equation. Draw the graph of this so it's vertically stretched. Be able to label your points, write your mapping rule, and give me the new points because, well, you're in grade 11. If you can get to the new point, if you can generate the proper points, I trust you all can plot points. I'm not sure if that's a valid assumption, but so those are the two things that I will put up today. I'll put that completed bit up. And that I think is all I have to say for now. If anyone has any questions, we got all sorts of people here. Some mostly familiar faces. Some of you haven't seen in a while. Everybody good? So far, so good?
I have a question.
Shoot. Go for it.
How long will we have to do the assignment? Like, when will it be due?
Oh, probably at the earliest next week, like the end of next week. Like it's not any of the, and I've said this for people who haven't been here all that often. It's like technically you have an assignment that's due tomorrow. Well, if you finish it and do it by the middle of next week, it's about doing it more so than deadlines now. I mean, eventually there has to be a deadline for everything because it's like, well, come the middle of, as far as I know, come the middle of June, everything will be done. And if you don't have stuff done, but I've had a couple questions about credit and no credit. And if the credit idea is because it shows on your transcript that you've done work and you've met minimum outcomes, which is important because if you look at universities, pre-calculus 12A is one of the courses they look at. Now, would UNB or Mount A or I would assume eventually it will get to most universities. It's like why it says credit is because of COVID-19, blah, blah, blah. Credit means, okay, you've gone through and done what the teacher asked. There's no mark because I can give little bits of feedback. I could give marks, but what do they mean? They don't mean the same thing. So if you're not worried particularly about that, but you still want to take 12B or calculus, well, if you go through and do some of the assignments, you're going to have the skills that hopefully you will have. You're all going to be allowed to register whenever that starts to happen for those classes. Um, but, oh no, you guys, oh, he must have snuck in. Ben was in his bedroom and then walked across the house. So even if you don't do any of the assignments, you can still gain knowledge. If you do some of the work, you pay attention, you listen, you see, you try little bits. The more assignments you do, like if I end up giving 10 different assignments and you've done 8 of them, okay, sure, credit. If you've done 6 and everything was perfect, probably, but if you do 3, it's like I can't say you like I've got evidence that you can do certain things but not everything. So that's I'm not going to like if all of a sudden you do them and they all come in at the end or the middle of June, it's like okay, well still you've done them and all of that. I don't know. There's some of you hopefully have seen the feedback. When I did the trig one, I just said question number 1 is good, question 2 check this one because there's a couple little tricks, but it's like I can't mark them like I would other things. But I'm not going to put there's no hard deadlines. If you don't have something done on Friday, but you do it eventually, yeah, sure, because it's about checks, not it's like okay, check you did the identities, check you did the transformations, check you did this, that, or the other thing. Sound good?
So, Mr. McKay,
Hi.
if I so pretty much everything for most of my classes are due tomorrow.
Yeah,
So if I give you like the last assignment on like Saturday, would that be okay? Or on the weekend?
yeah, sure.
Okay.
Whether it's Saturday or Sunday or next Tuesday, because right now I think I've got 8 or 7 of them. And it's like I know some people haven't been watching and some people are having internet issues and all sorts of stuff, but there's no penalty for late work. I'm not gonna. To me, it doesn't make sense to. Okay, this is a whole different situation than anyone's ever had to deal with. If you're, I know a lot of you are probably, even though the district says you should only be trying to get 2 to 3 credits, um, most of you are probably shooting for 4 or 5. So, and I have a whole bunch of you for 2 classes. So if you need a little bit of time, as long as things get finished eventually, I'm I'm happy with it because according to the thing, it's up to me, not so much up to in consultation with the principal. So, well, okay. Uh, so technically, it's more my decision. So that's good. I'll post those couple of things. I'll try to kind of edit that assignment and post the assignment, the questions that I want you to do, because for this one, it's just easier to use that document. And we will see you guys tomorrow, unless there's no other questions. Unless there is any other questions. Oh dear.
I'm good.
Awesome. I will see you guys all tomorrow then.
Thank you, Mr. Potato.
No problem.
Thanks, Mr. McKay.
No problem.